Oh, hi there. Welcome to Shashwat's Cook Show, a show where we have fun with mathematics and make mathematical dishes. On today's menu, we're making the Pythagorean dishes, a recipe I find very interesting and one I'm just researching right now. On today's platter, it consists of one meaty main course and three appetizers. But first, we need to reveal the most important ingredient for today's cook show. The right-angled triangle. I love the right-angled triangle, and so do many others. The right-angled triangle is a triangle that always contains a right angle, which means that two sides are always perpendicular to each other. Now, in the case of triangles, defining a triangle by its angle doesn't really mean much in most cases. However, this triangle has some very useful properties that will make it very good for our dishes today. So, let us figure out how we actually make these dishes, shall we? Now, when it comes to the dishes themselves, they'll require some preparation. In particular, the appetizers come from the main. Now, when it comes to the dishes themselves, they require some preparation, and the appetizers themselves come from the main course. So, let us start with the main course dish, for which we'll need 4 identical right-angled triangles, which I've got. Oh, one missing. Right there. We've got 4 identical right-angled triangles. Now, the main dish for today is called the Pythagoras theorem. And it is one of the most elegant mathematical dishes that we can actually make. And this was first made in the BCs, I can't exactly remember when, by Pythagoras. Now there are many ways that we can make this recipe, but I want to use the original by Pythagoras, and it is one of the most elegant ways. And now that we have our 4 right angle triangles, all it requires is some rearranging. So let us first place all of these right angle triangles on our paper, and let us label their congruent sides. So now the congruent sides are the sides that are the same. So let's label all of these sides as A, all of these sides as B, and all of these long ones as C. Now we can arrange these sides in a way that they form a tilted square, and we have to make sure the longest side is always the one that is actually inside. So let us do that. Now while I form this, you can start thinking about how this could be useful in our recipe, as that might help you later on. You know, it's very important to have that intuition as a chef, especially when it comes to mathematics. Mathematical dishes are extremely elegant. So now we can make all of the lengths, which is C in this case. Now, all of these sides were labeled as C, and all of these were labeled as A plus B. Let us just do the labeling. Now this square in the middle has an area of C square, and all of these remaining have an area of A plus B square minus C square. Now that is our first part. That itself is very interesting. But let us flip it over and do our second part. Now we can take these same ones and we can rearrange them a little bit. Let's arrange it like this time for these two. Let's take the other two and arrange them like this. Now this is also a very interesting arrangement, and I'd like to have you think of why this arrangement works in particular. There's a very elegant, there's a lot of eloquence that goes into these dishes. Now that we have these squares, we can do some very interesting things with them. So, because these both are like this side is D, And because this was like this, there's also a A here. So this part is the A. But there's also B over here. So there's a B over here, and because there's an A over here, there's an A over here. And there's also an A over there. But because there's an A over here, there has to be a B over here because this forms a square. Now we can actually separate, we can mark these off separately by doing that. So now this area is a square, and for the other two, because they are occupying these areas, again it's not quite perfect, but because they're occupying these two, the other one from here can be sectioned off once more as b square. It's another square. And again, in this case, the remaining ones are still there, which is the ones that were occupied. So you can say a plus b square, and then the remaining areas, and these ones are a square plus b square. But now look at what we have done. Over here we have minus c square, and over here we have minus a square plus b square. However, remember that these areas that were occupied by these triangles, since they are identical triangles, they have to be the same. And because they're the same, that must mean that this area that we just found right over here has to equal this area that we found over here. And that is our theorem, which is that a square plus b square equals to c square. And that is our main course for today. Our main Pythagorean dish. An extremely elegant dish. A square plus b square equals to c square. However, let's not just stop there. Now that we are done with our main course, as I said, we can use this for some appetizers. Now there's 3 appetizers, and for this we will need an additional tool. And this tool is called Trigonometric ratios. Very confusing word, sounds very long, but let us quickly explain it using another right angle triangle. This time I got 3. You're going to need 3 for this dish, and this one's a bit bigger. So let us put these ones away and get a new piece of paper. So we can take this right angle triangle next. Let us say this triangle also had sides ABC, A, B, and a C, and there's an angle. Now we can call this angle whatever we want, but standard notation often calls it theta. Now this is just some Greek notation that is used often. So now this triangle can have a few ratios. There can be a by C, there can be a B by C, so there's a A by C, there's a B by C, but there can also be a by B, so there's a A by B, and then there's the opposites that are also there. There's a C by A B by C, there's a C by B, and lastly there's a B by A. Now we can define these in terms of theta, because in this case A is always opposite to theta, B is always next to it, and C, well, that's just the longest side. That doesn't matter depending on what theta we take. Now the Greeks came up with names for these. They called A over C in this case as sine, B over C as cos, A over B as tan, C over A they called as cosec, C over B they called as sec, and B over A they called cot. The full forms are sine, cosine, tangent, cosecant, secant, and cotangent. And these 6 we can use for our triangle to make our appetizers. Now, for this we'll have to actually break down the triangle into different components. For this we'll have to use the flame. So let us get to cooking the actual 3. The first one, well, I'm going to need some I want to put this one under the flame of C square. Let's turn C square. And just let it simmer. Maybe open up this. And let's just go back and see what the results are. So what we are doing first is that we divided this. So the first time, so right now what we just did was divide this what we just did using the flame was divide all sides by c square. So let's see what happens, and let's use Pythagorean theorem for this. We just derived. This is why we need our main course for this. So we divide all sides by c square. Now c square by c square is just 1, and a square over c square we can turn into a over c square. This one can be turned into b over c square, and that one's just 1. But now we can see this one was the angle we defined earlier as sine theta, and this was the angle we defined earlier as cos theta. So now we can just say that sine, in this case we write sine square theta instead of sine theta square, because that would imply that theta is the square, not the sine. So sine square theta plus cos square theta equals 1. And that is our first Pythagorean recipe. Pythagorean appetizer. We just cooked the Pythagorean theorem, that was our main course. But that's our first Pythagorean appetizer. So last time when we cooked under c square, all the sides were divided by c square. So let's do b square this time. The flame's still hot. So let's cook under b square. Always make sure to be careful. And let's just let it kind of simmer. See what happens. And let's see what happens on the other side. So now we just cooked the next one using the flame at b square instead of c square. So let us see what that yields. So we had a square plus b square equals c square. Now we cooked it under b square. So we divide all sides by b square. Now b square by b square is just 1 again, and we can do the same thing we did last time. Root a square by b square is a over b plus 1, and this one can go as c over b. Now something you will notice extremely interesting here is that a over b was previously defined. This over here was tan. So we can say tan square theta plus 1 equals, and now c over b square, not c over b square, c over b whole square, we define c over b whole square as sec. So now we can say sec square theta, and that is our second Pythagorean appetizer. And now our Pythagorean dishes are almost complete. We just have one more left, and for this we'll be cooking under the flame of a square itself. Finally, we have just one more triangle left. Now this triangle we have to cook under a square. So let's put it there. And let's turn the flame of a square. Okay? This one's probably happens for this. All of these are just getting faster and faster. It always happens when you make these dishes. Each one just gets faster and faster. And let's see what happens on the other side. So now that we cooked under the flame of a square this time, so let us take this again. And divide all sides by a square this time. Now a square by a square is just 1, and we can do the same thing we did last time, 4 times. B over a square and then c over a square. Now you'll notice b over a is just cot from last time. We have 1 plus cot square theta and c, and that is 8 for today. Now there are a lot of mathematical dishes that we'll be cooking over at Shashwat's Cook Show over the coming years. But I hope you really enjoyed our first part, which was the Pythagorean dishes. There's a few more Pythagorean dishes I wanted to cover today. However, those are a bit more difficult to make. Today was more of an amateur episode. But if you want to see the next part, if you like and comment on this video, we'll be covering the next part, which is some slightly more advanced dishes that you can also try at home. Thanks for watching. See you next time.